The James Webb Space Telescope has, as of late, sent Earth an immense admonition. Furthermore, it's moving closer. This alert comes from the exoplanet Proxima B. With each new picture sent back, extra questions arise, leaving specialists overreacted. Each portrayal from this far-off planet makes us wonder more about the secrets of the universe. Developing requests are emerging about a potential unfriendly planet near Earth. Might there be a connecting outsider planet with disagreeable expectations? Could Proxima B represent a danger to our actual presence? The subject of outsider life has enamored humanity for quite a long time. Yet, with present-day innovation like the James Webb Space Telescope, it has turned into an inquiry we can investigate more completely than any other time in recent memory. However, the universe isn't making it simple to find answers. We proceed to utilize our best apparatuses, for example, the James Webb Telescope, to catch looks at far-off planets and systems, wanting to find pieces of information that could allude to life beyond Earth. We should be realistic. Each new picture and piece of information frequently helps us to remember how little we genuinely know. While these disclosures could be significant, they additionally feature the immeasurability and intricacy of the universe, leaving us with additional inquiries than responses. Understanding a far-off planet like Proxima B could rethink our place in the universe. For cosmologists, this is invigorating, yet for the overall population, it frequently feels like simply one more piece of space news, far-off, theoretical, and sometimes overwhelming. These revelations raise additional issues than they reply, driving numerous to consider what this implies for life on Earth. Might Proxima B someday truly harbor life, or even canny life that might one day represent a danger to us? Regardless of the enormous force of the James Webb Space Telescope, it can show us so much. Sure, we've taken in some inconceivable things, like the way that we presently have dazzling new pictures of Proxima B and that the universe is a lot bigger than we at any point envisioned. Yet, what comes next? The down-to-earth ramifications of these disclosures can feel as gigantic as the universe itself. Proxima B, found in 2013 due to its gravitational collaboration with its star, was a huge logical leap forward. Finding this exoplanet was like discovering another astronomical neighbor. Proxima B is marginally bigger than Earth, and it circles its star like clockwork, making it a captivating subject for further investigation. From a logical viewpoint, the possibility of a different universe so near our own is exciting. Yet, for many individuals, it's difficult to connect with a place that is 25 light-years away. To put that into perspective, even the quickest space apparatus humans have made would require millennia to reach it. Envision what it very well may resemble to stand on Proxima B. Its star, Proxima Centauri, would show up as a major weak red light in the sky, a lot cooler and dimmer than our Sun. Proxima B circles rapidly to such an extent that a year there endures a little more than 7 days. One side of the planet generally faces the star, meaning it is secured in continuous daylight, while the opposite side is covered in never-ending night. It sounds like something out of a sci-fi novel, however, the truth would be undeniably more ruthless. On the brilliant side of Proxima B, any water would almost certainly bubble into steam due to steady openness to heat, while on the clouded side, it would freeze into solid ice. The planet's star, Proxima Centauri, is additionally not a calm, consistent neighbor like our Sun. It discharges risky flares and extraordinary radiation, making the outer layer of Proxima B a threatening spot for life as we know it. This isn't the very kind of neighborhood where people would want to settle. Interest in tracking down life beyond Earth crested in late 2020 when researchers identified an uncommon sign coming from the Alpha Centauri system, where Proxima Centauri is found. This signal had a remarkable recurrence of 982.551 MHz, which grabbed everybody's eye. Such a sign could hypothetically be an indication of trend-setting innovation, however, it's too soon to reach any conclusions. More as of late, the James Webb Space Telescope began to suggest even greater energy by proposing that Proxima B could have water vapor in its atmosphere. Water, as we know, is a vital element for life, and its presence could be a game changer. To better understand how much water is present on Proxima B, researchers are utilizing advanced methods like spectroscopy. This strategy permits them to identify the gases encompassing the planet, acting as an innovative investigative tool. By breaking down the planet's light spectrum, scientists can distinguish explicit gases like oxygen, methane, and carbon dioxide, which are fundamental for life. Environmental modeling is another pivotal move toward utilizing computer simulations of Proxima B's atmosphere. Researchers can make reasonable deductions about its conditions. These models serve a comparable purpose to how scientists use dinosaur fossils to understand what dinosaurs could have seemed like. However, the more we find out about Proxima B's atmosphere, the more we are reminded of the staggering assortment of living things that exist here on Earth. Extremophiles, for example, are tiny creatures that can survive in outrageous circumstances, bubbling hot springs, acidic lakes, and the freezing cold of Antarctica. These versatile animals demonstrate how life can adjust and flourish under conditions once thought impossible. Could life on Proxima B be similarly as adaptable? The quest for life on Proxima B presents huge challenges, not just concerning space travel but additionally in demonstrating that life can exist in such an unfriendly environment. The planet is assaulted by extreme space radiation, and its atmosphere could not offer much protection. Furthermore, the distances involved are so vast that new types of propulsion systems are necessary to make space travel to Proxima B possible. Ideas like solar sails, ion drives, and even more hypothetical concepts like warp drives offer invigorating opportunities for future exploration. However, these advances are still in their earliest stages and require broad research before they can be utilized in real missions. While dreaming about future space travel is exciting, we really want to stay realistic. Tracking down life on Proxima B is loaded with challenges, mechanical and logical difficulties, exclusively by propelling our innovation and extending how we might interpret the universe. Might we at any point desire to open the full capability of far-off worlds like Proxima B? This pursuit isn't just about fulfilling interest, it's tied in with pushing the limits of human accomplishment. Might we one day set foot on Proxima B or even interact with life there? As we consider the long excursion to Proxima Centauri, finding outsiders does not feel any more restricted to the domain of sci-fi, but instead appears like a truly conceivable undertaking. This interesting movement from a far-off dream to a logical adventure has drawn in serious consideration from cutting-edge associations like advancement drives. These gatherings are committing gigantic assets to changing what might regularly be an inconceivably extensive excursion, one that could require a huge number of years, into a mission feasible within many years. The objective of arriving at another star framework within a human life expectancy has ignited development and good faith in mainstream researchers. Anyway, these excellent aspirations are immediately tempered by the unmistakable realities of our ongoing innovative constraints. In spite of amazing headways in space investigation, venturing out to Proxima Centauri, indeed, even at 4.2 light-years away, still presents overwhelming challenges. Current drive frameworks are basically not quick or productive enough to make such a venture conceivable in any sensible timeframe. Advancement Starshot, one of the most striking activities, imagines utilizing strong laser-driven sails to move little rockets to speeds up to 20% the speed of light. While this idea shows guarantee, it is still in the exploratory stage and requires overcoming various mechanical and logistical obstacles, for example, limiting harm from space garbage and guaranteeing exact long-distance correspondence. While the fantasy of arriving at Proxima Centauri and possibly finding outsider life is closer to it than ever before, it remains compelled by the limits of present-day innovation. Speeding up a shuttle to approach light speed with the present apparatuses feels nearly inconceivable, like attempting to settle a complex riddle in obscurity. Even striking drives like Starshot, which plans to drive a space apparatus toward Alpha Centauri utilizing lasers, face significant viable challenges. Earth's environment causes unsettling influences for the lasers, making it hard for space investigation instruments to work with the accuracy required. One proposed arrangement is the utilization of versatile optics, smaller lasers on satellites that ceaselessly screen and adapt to barometrical unsettling influences. This framework would help strong ground-based lasers remain fixed on space apparatus as they travel through space. Anyway, the laser drive technique requests a tremendous measure of energy comparable to the aggregate energy consumed by the whole United States, and it would only work for a brief time frame. Envision setting up 100 million lasers over an immense region just to push a little rocket, only 33 feet wide, to 20% of the speed of light. At this speed, the rocket would in any case require 22 years to arrive at the Alpha Centauri framework, a period of time longer than many individuals' lifetimes. Yet, the test of coming to Alpha Centauri isn't exclusively about defeating specialized impediments. There are normal obstructions also: the sun's gravity, the presence of room flotsam and jetsam, and the sheer massiveness of the distance implied all pose huge dangers. Alpha Centauri is a considerable test. The huge distance of 4.2 light-years may not appear to be difficult in the vast scope. Be that as it may, for human investigation, it addresses an enormous obstacle. With current innovation, even high-level missions like Starshot would require a long time to come to the framework. Correspondence delays alone would require years. Signals from Alpha Centauri would assume control more than 4 years to arrive at Earth, making real-time trades incomprehensible. The excursion to another star framework presents strategic worries too. Spacecraft moving at rapid face crash risks from interstellar residue or flotsam and jetsam, which at such speeds could make devastating harm. Alleviate these dangers. Future missions might require high-level protecting or mechanized route frameworks fit for distinguishing and keeping away from dangers. Moreover, power hotspots for such significant distance missions are a critical imperative. Frameworks need to freely work, possibly for a really long time, with restricted or no support. Advancements in impetus, energy capacity, and correspondence will be important. The prospect of experiencing extraterrestrial life on Proxima B or some other exoplanet is both exciting and overwhelming. For some, outsider life brings a feeling of wonder and interest. Anyway, it likewise raises inquiries regarding the ramifications of such a disclosure. On the off chance that we view as microbial or even intelligent life, would we endeavor correspondence, or would caution win to stay away from unseen side effects? The moral and existential inquiries tied to outsider life are significant. Would humankind's spot in the universe be reimagined? How might contact with outsider life alter how we might interpret science, society, or reasoning? Ultimately, humankind's excursion to the stars isn't simply a logical pursuit, but a striking adventure into the obscure, full of dangers and prizes. Whether we find new universes with life or infertile far-off scenes, every disclosure reshapes our comprehension of the universe and, thusly, our own personality within it. For the time being, the James Webb Space Telescope and other future innovations keep on bringing us closer to answers, enlightening the way forward and helping us to remember the perpetual secrets that lie past our span. Proxima B would need to send messages through time. It would expect around 4 years for a sign to show up at it from Earth. Disregarding these staggering provokes, the longing to investigate other star frameworks keeps on developing. It's driven by humankind's well-established love for disclosure and investigation, rather than pragmatic need. Even aggressive adventures like Starshot, which expects to push a shuttle toward Alpha Centauri utilizing lasers, face various useful challenges. Anyway, tackling these issues could change space investigation. Still, the potential dangers implied, counting correspondence delays and regular perils, require cautious preparation. Notwithstanding the difficulties, numerous researchers trust that the prizes far offset the dangers. Tracking down life on Proxima B or one more far-off exoplanet proceeds to enrapture minds overall. Finding life on another planet would be the most amazing logical disclosure in mankind's set of experiences. It wouldn't simply reshape how we see ourselves and our place in the universe, but could likewise give bits of knowledge into the beginnings and destiny of life on Earth. While humankind longs for a future where we can travel to the stars, we are additionally making functional strides in our quest for life. The revelation of planets like Proxima B is just the starting. Telescopes like Kepler have been instrumental in identifying far-off universes that might actually support life by seeing how these planets